to maintain the bridge gap between the industry and academia. So for a curriculum as a practical, a real world experience. So it is an emphasis is a well-around education that GMRT makes a preferred institution among the engineering college across the India. To show, to prove, so we are also tie up with a different collaboration with the other university, another industry and university for the abroad. So one well known the MOU with the Luca industry, Germany. They are producing the lightweight concrete. They are tied up. We are interchanging the collaboration with the product development and etc. Then we have MOU with the University of the Petronas. We are collaboration with the faculty and the training, exchanging the program for the students as well as the faculty members and research collaboration. This is about glancing for the departments. Okay, thank you very much, sir. I wish you all the faculty development will be successful for all the 6 days. Thank you for opportunity given for Gokulan. Please, you start the session for the Gokulan.
Okay, thank you, sir. Thank you for your warm welcome. Now, I request our Dr. S.S.G. Prasad, sir, to give a brief introduction about our chief guest.
Good evening, all of you. Sir, can you hear me, sir?
Yes, sir.
Yes, sure. Yes.
Good evening, all of you, and good evening, the chief guest, today's chief guest, Dr.Abdul Rahman Mohd.Sam, and good evening to all the faculty members, those who are joined today. So today I would like to introduce Dr. Abdul Rahman Mohd.Sam. So he was born in 1965 and known as the caring and dedicated lecturer in the Department of Structure and Materials, School of Civil Engineering, University Technology, Malaysia since 1988. So he has obtained his PhD degree in 1999, so from the Sheffield University, UK. So currently he is the director of UTM Construction Research Center. So he also has the experience to be the head of the Construction Materials Research Group. So since July 2015 to February 2017, and Vice President of the Concrete Society of Malaysia. So from 2016 to 2018, so Director of UTM Equi Center from 2010 to 2014. So has vast experience related to the design of equi infrastructure, caring of horses and horse-related activities. So besides teaching, so he is actively involved in the research work. So he has supervised almost 25 plus PhD students, and he has published almost 81 plus indexed journals, and he also involving in the consultation work also. So he has written a original book, Concrete, so in 2017, so published by the Penrib UTM Press, and as editor for the book entitled of the Sustainable Construction Using Waste Materials, so in Malaysia, published in 2019. So his field of expertise is especially in the concrete technology, so green and sustainable construction and advanced composite materials, so including but not limited to the strength of the durability of the concrete, so high performance concrete, so high strength concrete, so fiber reinforced concrete, cement replacement materials, so waste materials in concrete, sustainable concrete, self-healing concrete, self-curing concrete, so EM in concrete, so nano materials in concrete, so concrete strengthening and repair using the advanced composite materials. So as a concrete man, so one of his main concern is how to disseminate the knowledge so related to the concrete to a greater audience. So with the aim of enhancing the quality of the manufactured concrete, so in practice that satisfy all the design criteria required, especially related to the strength and durability. So with this brief introductions, I would like to welcome our chief guest, Dr. Abdul Rahman Sam sir. So hand over to you, sir.
Thank you, Dr. Gauri Prasad. And also thank you, the head of the department, Professor Dr. Wijaya Kumar, for inviting me in this program. So thank you also to Mr. Gokul.
Yeah, thank you, sir.
The one that we met in 2017, isn't it? Yeah.
Yes, sir. Yes, sir. 2017.
Yeah. Okay. All right. So I hope that everybody is well, is okay.
Yes, sir.
Uh,
Yes, sir.
everybody should take care at the moment. So same thing in Malaysia. So we have this pandemic, is COVID, the same thing lah all over the world. All right. So please bear with me for just a few minutes to share with you all. Because this is what you call it as a faculty development program, isn't it? Faculty
Yes, sir.
development program. So we are sharing lah. It is not teaching you all, but sharing. I hope that we can communicate. We can interact during whatever our session. Over the things that I share with you. Let me check. Hopefully it's okay. All right. Can you see it?
Yeah, it's visible, sir. You can proceed. It's
Okay.
visible.
All right. So thank you. All right. So again, thank you very much for inviting me. So it's a privilege for me that Gokul still remember me. Okay. Now Indonesia is 7:45. Over there is what? 5:30.
Yeah, now here it's 5:15, sir. In India, it's
5:50.
5:15. Yes, sir.
Okay, so 5:30. So more or less, we will finish just within 1 hour lah, so that everybody can do whatever that our daily life. All right.
Okay.
So here it is not meant that I'm teaching anybody. So this is just sharing session. So I do believe that some of us, our participant, that in our discussion here, more knowledgeable than me. So we are sharing. If let's say you have something new, then you can share with me also. No problem. So for today's topic, we try to discuss in terms of concrete, which is my field. Is concrete on material. We want to look at just overview of the current and future technology. So as we know that the use of concrete nowadays, probably 70% all over the world, the use of concrete in our construction industry. So at least we know the fundamental. Before we discuss the latest technology, the up-to-date technology, but the fundamental related to concrete we must understand lah. Okay. All right, so this is UTM, University Technology Malaysia. So hopefully one day you can visit us in UTM. Welcome to UTM. So this is our School of Civil Engineering lab. It's a big lab actually. Okay. All right. So normally student, master student, PhD student doing research work here. And then this is our civil engineering, School of Civil Engineering. Our vision, mission, and our motto lah. So we want to be world-class center of education, to spearhead excellence in academic and also ahead. So which means that also ahead. So we need to update our knowledge from time to time. We must be always ahead from the current, the current knowledge. All right. So thank you again for the JMR IT for inviting me. So I believe that few more presenters with different topics, application of remote sensing and agricultural waste in concrete wealth, corrosion of steel reinforcement in concrete structures, causes and protection, green construction technologies for sustainable development, pervious concrete for sustainable construction, and also air quality during construction and water for construction. So these are very good topics to me, so that that we can enhance our knowledge on that. So this is my photo. I still have this photo, Gokul. Okay, in 2017. Okay.
Yes, sir.
Okay, and then if you remember Gokul, so
Yeah.
this is very nice. This food,
Okay.
what we call this? Biryani, isn't it?
Yeah, sir. Indian Tamil Nadu biryani famous.
Okay, very nice, very nice.
Okay.
Very nice. So thank you very much. So I still remember,
Yes, sir. Thank you, sir. Thank you.
I still remember that. All right. Okay. So for today's sharing, again, this is a sharing session. It's not teaching anybody. Sharing session, whatever that I know, so we can share good meaning to the knowledge we need to share with others. So what we need is knowledge. So to get the knowledge, it is not something that only official, but an official unofficial method also can to get the knowledge. It is very important to have a knowledge. Anything you need, we need a knowledge. All right. So for today's sharing session, what I want to highlight is related to what is concrete and why we need to understand about concrete. Why I say so? Because everybody, our house, our office buildings, most of the time, we use concrete, reinforced concrete. So at least we know about concrete. Okay. What are the current practice of concreting on site? What are the things that they do? The things that make sure that the quality of the concrete is there. And then we try to look some of the problems related to concrete. Why this problem occur? How to minimize, or how to eliminate this problem. And then towards the end, we just get to know the what are the future technology in our concrete. So if let's say for anybody who interested in concrete, specialized in concrete, so this book, Properties of Concrete by A.M. Neville, this one, is very good. If let's say you want to get hold of this and you can read through, and then it's very good. Okay. So this is Kuala Lumpur at night. The view of Kuala Lumpur at night. Okay. So a lot of tall buildings. So most of the tall buildings are constructed using reinforced concrete. So when we talk about concrete, so probably everybody understand about concrete, but not everybody understand the fundamental of concrete. Okay. So that's why sharing session is very important, very good for us to enhance our knowledge related to concrete. Okay. So from the ingredients, we mix fresh concrete become hardened concrete. So these are the process. Why we use concrete? Because concrete can be one of the most durable material in construction, provided that we design properly. Okay, and then we can design to whatever the standard required. Okay, so that is very important. And then concrete can be used for structural and non-structural. And another one is it is the second most used material after water in our construction industry, in our world. All right. So we know concrete. We know reinforced concrete. So what type of concrete that we want to use for different application? So these are the most important thing when as engineers, the one who deal with concrete. So this is very important to understand what type of concrete for different application. For structural, non-structural. If let's say for structural application, so what type of grade of concrete that is required? So this is very important. Okay, so this is our dream house. Yeah, everybody wants to have a very nice, big house, bungalows. Okay, this is our highways. A lot of constructions going on everywhere in the world. This is dams. Offshore structure. So for offshore structure, what are the requirements? What's unseen in seawater? So normally, marine environment is very aggressive to concrete, reinforced concrete, because it contains sulfate and also chloride. So these are the things that we need to understand. And then sometimes we need to construct our structures in this type of area. It's very polluted area. Polluted area can cause acid rain. So this is a thing that we need to bear in mind. All right. When we talk about concrete, so these are the main ingredients. We have cement, aggregates, fine aqueous aggregate, water, and also admixtures. So basically, these are the main ingredients that we use to produce different types of concrete. All right. So when we design our concrete, so the most important thing is that our concrete must be workable. So in terms of workability, workable concrete, and also our concrete must be designed based on the strength and durability. Strength and durability. So which means that the strength probably grade 40, grade 30, grade 50, and durability is what is the lifespan of the structure. Probably 70 years, 100 years. And then in order to get that strength and durability, so the concrete must be dense. So how to get the dense concrete? So these are the things that are the fundamental that everybody who deal with concrete should understand. All right. So basic requirement, strength and durability. So we need to consider strength related to load, durability related to surrounding environment. If let's say our structure is near the marine environment, so we need to tackle for the durability problem. All right. So related to strength, so we have different grades of concrete. Normal strength concrete, high strength concrete, and then on durability aspect, so we make sure that the concrete is dense, very dense. So how to make sure that concrete dense, so that the concrete contains more CSS gel. So it's very important, and also the curing process. So this is the one that probably sometimes is overlooked in terms of the curing process of the concrete. Okay. Again, these are the why we use concrete. Can be designed, requires strength, good compression. However, concrete weak in tension. So that's why we have reinforced concrete, combination of concrete and steel. Okay. And then concrete is by nature is porous material. So which means that we design to make sure that the concrete is less porous. And less porous. And then concrete, the environment is alkaline environment, so that it can protect the steel. Okay. And then concrete, we can say concrete is a life construction material because it gains strength with time. Okay, it gains strength with time. So the most important thing is that the concrete must be less permeable. The concrete must be less permeable, so that whatever the aggressive material outside cannot penetrate into the concrete. And because we want to protect the rebar, reinforcement. Okay, one of the main factors that will affect the quality of the concrete, the strength, the durability of the concrete is the water-cement ratio. Okay, so the higher the water-cement ratio, the lower will be the compressive strength of the concrete. Okay, and then the lower water-cement ratio improve the compressive strength. So for high-strength concrete, so definitely we need to use low water-cement ratio. However, when you use low water-cement ratio, so the problem is on the workability. So there's no problem nowadays because we have admixtures. We have chemical admixtures. So this one. So admixtures in concrete. So we have chemical and also we have pozzolanic. Pozzolanic we use to replace part of the cement content. Admixtures probably okay. For example, retarder. So this is used for the ready mix batching plant to transport. So pozzolanic material, example of fly ash like silica fume, it contains reactive silica that react with calcium hydroxide from the hydration process of cement that producing more CSS gel. Again, the formation of CSS gel is very important in our concrete to ensure that the concrete is dense. Alright. So chemical admixture. So normally we have 4 accelerator, retarder, water reducer, and trainer. So normally for air antenning emissions are being used for seasonal climate countries. We have winter, we have summer. That one. In Malaysia, we don't have seasonal climate, so normally we don't use air antenning. So normally we use retarder and also water reducer. Okay. And then pozzolanic material. We said that is blended cement concrete. Okay. Using waste material, because fly ash, slag, these are the waste material, but it contains reactive silica that can be used to replace part of the cement content. So which means that we reduce the use of cement in our construction. All right. So to produce good quality concrete, to produce good strength, durable concrete, so we must select good quality material. We must select good and the best quality material. Plus, we have knowledge on that. Because if, let's say, we understand about concrete, but in terms of the knowledge, fundamental knowledge is we are not very familiar with concrete, then we cannot produce the right type of concrete that is required. All right. So, as engineers, as civil engineers, the one who deal with concrete, we can face so many problems. We can see so many problems related to concrete. So our task is to solve the problem, find the solution of the of the problem. So in order to find the solution of the problem, so we need knowledge. All right. So nowadays, the term of sustainable concrete, sustainability in construction, sustainable construction, and so on. So it is something that we need to also consider. Probably, if let's say we talk about sustainable, so what are the people's demand? Housing project, the cost, in terms of the economic, in terms of the environment, the CO2, depleted natural resources. So this one related to material. So in order to reduce the CO2, so we need to reduce the use of cement. In order to reduce the use of cement, so we use pozzolanic material, the waste material, that one. Okay. So these are the things that we need to understand. Okay, how to use construction material in the most efficient way. So let's come the technology. So how we want to improve. For example, if let's say 20 years ago the strength of the concrete grade 30, but nowadays we can make grade 60 easily, because we have all the ingredients to produce that type of concrete. Okay, and then in order to use material efficiently, so we need to innovate something. For example, nowadays we have polymer modified cement, nanoparticles in concrete, the use of recycled material, the use of CO2 absorbing material in concrete. So these are the things that innovation required nowadays. However, in order to innovate something, so the fundamental we must understand. So it's very, very, very key important. Okay. So we cannot deny that we learn also from nature, or nature teach us how to do something. For example, for this orange, for this coconut, so in order for the inside being protected, so they have this like a shell here, coconut shell, isn't it? So these are the things that we if let's say we are thinker, then we understand how. So when we relate to concrete, reinforced concrete, so we have this concrete cover to protect steel. We have concrete cover to protect steel. But if let's say the concrete cover is low quality, so how can this low quality concrete cover protect steel? So this is the problem, one of the problems. Okay. So again, if let's say the shell is very porous, so what will happen to the inside? So it cannot protect the juice inside there. Okay. So these are the things that we need to understand. Okay. All right. So for concrete, the pH is about 12 to 13, so that it can protect reinforcement from corrosion, by forming one passive protective layer here. Okay, so for corrosion to occur, so it requires steel, it requires water and also oxygen. Okay, so the functions of this concrete cover, among others, is to protect oxygen from outside, water from outside from penetrating into the concrete, reaching to steel. So if less can be done, so the steel will be protected. But unfortunately, sometimes we don't understand that concept. So sometimes we demold the formwork early, and then we don't provide a proper curing process. All right. So when we talk about cement, when we talk about concrete, so we cannot run away from cement. So in cement, so we have the chemical composition. Chemical, we have C3S, C2S, C3A, C4AF, whereby C3S and C2S provided the strength to the concrete. Okay. C3A and C4AF, which is tricalcium aluminate and tetracalcium aluminum ferrite. In terms of the strength, it's not significant. But for the C3A, it is prone to be attacked by sulfate. So if let's say that area contains a lot of sulfate content, so we must make sure that the cement that we select must have less C3A. For example, in marine environment, we have sulfate and chloride. Sulfate will attack C3A. So this is very important to understand. So the strength will be governed by C3S and C2S. Here C3A undesirable, but it's there inside our cement, and then it tends to be attacked by sulfate. So this is very important. So that's why if let's say our structure is near to the marine environment, it is not advisable to use just ordinary Portland cement. Why? Because ordinary Portland cement contains a higher amount of C3A, tricalcium aluminate. So that's why tendency for sulfate attack is higher. All right. So the use of blended cement. Blended cement means a combination of ordinary polycement plus calcium plus pozzolan material, fly ash or silica fume. Okay. So it will produce more CSS gel. So the hydration process of cement react with water, producing CSS gel plus calcium hydroxide. So this calcium hydroxide will react with reactive silica from the pozzolanic material, fly ash. So it produces CSS gel. So which means that we have more CSS gel. Once we have more CSS gel, okay, more CSS gel, so the concrete becomes very dense. So this is the concept. So in order to protect, in order to increase the strength of the concrete, in order to make the concrete durable, less permeable, so the concrete must be dense. So the idea to make the concrete dense is to use blended cement, which is a combination of OPC plus pozzolanic material. So this is an example. If let's say we use silica fume, this is 0%, 5%, 10%. At 28 days, the strength increase. Why is strength increase? Because the formation of more CSS gel, calcium silica gel. So that is the concept. Okay, so we want our concrete dense concrete, but in different aspects. So sometimes we need porous concrete. That is different concrete, different type of concrete and different application. For now, for the strength application, structural application, so we need our concrete to be very dense. And then the quality of the concrete. The concrete by itself, if let's say we manufacture properly, so it can be, I would say, impermeable to water. Okay, but we need to make sure that the concrete is made properly. All right. So the basic fundamental of concrete, so that everybody should understand is in terms of when we design our concrete, we want our concrete to be strong, which is strength and durability, durable. So in order to get these two aspects, strength and durability, so the concrete must be dense. In order for the concrete to be dense, So the hydration process is very important. Okay, the hydration process is very important. So that cement react with water, CSS gel, producing CSS gel, and calcium hydroxide. And then this calcium hydroxide with silica from the pozzolanic material producing more CSS gel. So these are the concept. Okay, so if let's say our concrete is dense, our concrete is less permeable, so it can protect our steel reinforcement. Okay, Gokul, is it okay, Gokul?
Yeah, everything's fine, sir. Yeah, fine.
Okay, everybody okay? All right, okay. So if let's say you have anything, just stop me lah. Okay. All right. So nowadays we have no problem in terms of the source of concrete. So normally it's from batching plant. Ready mix. So this ready mix transport the concrete from the batching plant to the site. So normally that is the situation nowadays. All right. So if let's say the distance is too far, so we need to consider the timetable taken. So that's why we need to use retarder to delay the setting time. And then when it comes to the site, so the placing process, we place the concrete in the formwork, using whatever the method that we use. Okay, once we place the concrete, so we compact. So this is the method of pouring the concrete. So once we pour the concrete in the formwork, so we compact. The purpose of compaction is to eliminate oil voids, so that the concrete can be very dense. So that's very important, very dense concrete. Okay, leaving less void inside the concrete. So normally we use external vibrator, or we call that as poker vibrator. So the method of compaction also very important. We cannot just simply do the compaction without proper method. So the correct method is on the left side, which is the poker is very straight, and also from the first layer to second layer, so we can still compact. On the right side is the incorrect way lah, I would say. Okay, so this is very important. Okay, and then after compaction, once finished compaction, so the curing process is very is critical, very important, because we want to protect water from the concrete sample from evaporating. So that is very critical, to ensure the strength and durability of the concrete can be achieved. Okay. So this is the relation between curing, permeability, and curing. So the higher the longer the curing process, the permeability of the concrete will be low, reduced. The longer the curing process, the strength of the concrete will be higher. Why? Because the formation of the CSS gel will become higher. So that is the very important things. Okay. All right. So the strength and versus the time, for different curing process. Water curing, and then the bottom one is air curing. So we can see that there is a difference between air curing, which is not in water curing. So the one that we put in water is strength higher than air curing. Why? Because in air curing, some of the water from the concrete sample will evaporate. So this water, once it evaporates, so we have less water for the hydration process. So that's why curing very important. Okay. For example, if let's say we demol the formwork, after 1 day or 2 days we demol the formwork, so what to do? We cannot just leave it like that. So we need to do proper curing. If we don't want to do proper curing, just leave it the formwork for at least 7 days. Why 7 days? Because at 7 days, the strength of the concrete normally achieves 70% of the strength required at 28 days. So that is very important. So method of curing, no matter how, as long as we able to protect the moisture from the concrete evaporate outside, then it's okay. So that is the method of curing. We have wet hessian, spray, cover, plastic, bonding with water. So these are some of the method. As long as we cure the concrete. Okay. If let's say we demol the formwork and then we need to cure like this, and then we need to spray water. This is ponding. This one we need to spray from time to time. So not only we need workers, but we are wasting our precious this water. So these are the things that we need to understand why. Okay, so keep the form work intact for at least 7 days. Normally. Alright. So if let's say we don't put proper curing, so the concrete cover become porous because less CSS gel. Because of part of the moisture will be lost from here. So once the concrete porous, oxygen, water can penetrate, reaching to the steel, then corrosion start to occur. So that is the concept. Okay, so we need proper curing. So the problem is related to the curing, related to the compaction, related to the environmental surrounding environment. We cannot foresee if let's say for marine environment, so it's very aggressive to concrete. So we need to consider that. Okay. For example, like this, so this bridge. So this is seawater. Seawater, we have sulfate chloride, which is considered as aggressive to concrete. So we need to consider what type of cement, what type of material that we want to use. Okay, because concrete normally tend to crack. So cracks in concrete can be of different types and different source, different factors that causing the concrete crack. For example, if L, this one L along the reinforcement, L is a corrosion. If let's say E like this, E is the plastic shrinkage. So these are the things we need to more or less understand whether that crack is structural crack or non-structural crack. Okay, all right. So as designer, as people who deal with concrete, so we don't want this to happen. So the building collapse like this. So we don't want this problem to occur also. Because the concrete is not workable. And then we have this not what do you call this? It's not a honeycomb. Honeycomb is smaller size. But it's like a hole like this. So if let's say this happen when you demolish the formwork, so we need to do proper repair. Proper repair methods. If not, then we have a problem corrosion. Why? Because once the reinforcement start to corrode, then it will induce internal stress in our concrete. So once internal stress very high, so the concrete will crack. Once concrete crack, and then it start to spoil. Okay, so these are some of the problem. On the right side is due to corrosion. This one probably due to the load, overloading. All right. So that's why it's important for us to understand, to make sure that the concrete cover becomes good quality concrete cover. Curing process is very important to make sure that the concrete cover, which is probably 25 or 30 mm, 40 mm concrete cover, become good quality, less permeable concrete cover, to eliminate this problem, this sort of problem. So surrounding environment is very aggressive. Okay, so same thing here. Why this happen? If let's say we can see the concrete, the mix here, I think it's a less amount of cement. When we have less amount of cement, then become very porous. Let's say SS gel. So that's why the steel corrode. Okay, same thing. One example, if let's say we have this like the jetty, which is exposed to seawater here. The problems normally will become the corrosion. It will be the corrosion. Why? So there's many factors. Probably the use of cement, the different types of cement that we use. Probably they use only OPC, ordinary Portland cement. So the one that I said earlier, the cement content, the C3A content in Portland cement is higher. So this is very important. That is for us to understand. If let's say we do make construction in aggressive environment, so we need to understand what type of concrete suitable for that. Alright, corrosion. So this is very dangerous. Again here, exposed to seawater. What happened to the column? We have a problem of column. This column, cracking like this. Something like this, due to probably do sulfate attack. Or sulfate attack, and then concrete start to crack, then we have further problem. So if let's say exposed to seawater, so we need to consider the solution, how to solve the problem. Okay. Another aspect that probably I want to highlight is in terms of the spacer that we use in our construction. How good is the spacer? If let's say we design our concrete grade 40, is the spacer grade 40? If let's say the spacer just using mortar, it's not just normal mortar, low quality mortar, then it's become the door and the window for the aggressive material to enter, reaching into the steel. So this is very important. Sometimes, and then in order to solve so many problems related to concrete, especially the corrosion problem, so we have special concrete. If let's say the problem of construction, for example, here it's very we need to pour concrete at the faster rate. So we make sure that the concrete can be pumped. So we have pumping concrete. How to produce pumping concrete? How to design pumping concrete? So obviously we need to use chemical admixture. Obviously. So sometimes we need to do construction in area or places like this, very large area. And then sometimes we pour the concrete 24 hours non-stop. So these are the aspect that nowadays we call that as consider as special concrete, flowable concrete, pumping concrete, self-compacting concrete. Okay, but the fundamental concept of concrete the same. The concrete need to be designed properly. The concrete must be workable. The concrete the different types of cement for different application. So these are the things that we need to bear in mind. This is pumping concrete. So what happens if I say a very large area like this? So the problem of plastic shrinkage may occur. So in order to solve that problem, so probably we can use fiber reinforced concrete. Alright, so mega structure like this, very big, very large column. So obviously the strength of the concrete must be high strength concrete. And then the types of concrete, flowable concrete, so that it's easier to do the concreting process. Continuous concreting. All right. So another aspect is because concrete is less in terms of the tensile strength is very low, which is about roughly 10% of the compressive strength. So in order to improve the tensile strength of the concrete, so we can add short fiber, so become fiber reinforced concrete. It's special concrete, fiber reinforced concrete. Okay, so this is the short fibers. So normally, if I say for structural application, we use steel fiber. So we have a polymeric fiber, we have steel fiber, we have natural fiber. But for structural application, so normally we use steel fiber. Okay, so we can solve the problem of weak tensile strength of the concrete. We can solve the problem of the brittleness of the concrete. Okay, so we use short fiber. So this is different shapes of steel fiber. Okay, so the idea is when we have this fiber reinforced concrete, so it can increase the tensile properties of the concrete. Meaning to say that the strain of the concrete can be increased before it fails. Okay. So it depends. So meaning to be, because it's special concrete, so for the special application, so where we can use this type of concrete. For example, in area whereby we expect the impact load, for example. Alright. So to reduce the cracks, we use fiber reinforced concrete. This is 0 fiber. This is 0.2% fiber. So the amount of crack is less, because of the fiber. And then we have what we call as self-healing concrete. So normally concrete will cracks. If let's say for micro cracks, so if let's say the concept of self-healing concrete, so we can eliminate or reduce the maintenance cost. So nowadays this is one of the topic bio concrete, bacteria concrete, good bacteria lah. Okay, so these are Bacillus megateria, Bacillus sphaericus. These are some of the example. Alright. So this is crack. Once the concrete crack, so we have a bacteria inside here. So the bacteria will activate, and then it will create or form calcium carbonate, the white color, this one. So which means that it will fill the cracks. So this is the idea nowadays. Okay, self-healing. Within 14 days, within 3 weeks, you can heal the cracks. So not only we use bacteria, but sometimes we use polymer-based material. Polymer-based material. Okay, so this is the one of the current, the future technology that may be used in our construction. So the self-healing concept. Okay, so this one is one of my students doing this test. We took the sample of soil in UTM in Malaysia, and then we culture and then put inside the concrete. So this is without the bacteria. This one with bacteria. So the crack here is being filled with calcium carbonate. So this is the concept. Then we use microcellular. This one is using polymer-based agent, polymer-based material. So self-healing concept. Okay, so it's very important to heal the micro cracks, whereby the area whereby we cannot see the cracks. So it is very important to seal the cracks in that area. All right. Another one is in terms of the curing. Curing process is very important. Again, that I said earlier, curing is very important. What is the purpose of curing? Is to keep the water inside the sample. Okay, because sometimes the curing process is not done properly. So we introduce the concept of self-curing concrete. The concrete can we introduce certain material that will absorb more water, that will provide internal water reservoir. Okay, so sometimes we use lightweight concrete. So if let's say we use lightweight aggregate, yes, it can absorb water, it can introduce the internal curing process. However, it will affect the compressive strength. So we don't want that. If let's say no proper curing, so the quality of the concrete will be very low. Okay, so this is again the graph. If let's say we test concrete in lab, air curing, in water curing, so that the strength will be different. All right. So one of my students use this what we call as effective microorganism as self-curing agent. So we try to use this, whether it can be used as self-curing agent or not. So he also graduated. So from the findings, we can see that the effective microorganism, so normally being used for agricultural purposes, so can be used in concrete to enhance certain properties, some of the properties of the concrete. For example, in terms of workability, in terms of the pH, pH value. If let's say we use effective microorganism, the pH can be will be lower. So this probably good for bio concrete, bacteria concrete, because bacteria, if let's say alkaline environment very high, so it may not work well in for the bacteria. And also it reduces the shrinkage and expansion. Why? Because the microstructure of the concrete become different by using EM. So we can see that this is control concrete without effective microorganism. So the right one is the with EM. So these are our findings. So which means that EM reduce the permeability. Once reduce the permeability, it can increase the durability aspect. So this is the one that we find. Okay, and then another aspect of current concrete is on self-cleaning concrete. self-cleaning. So probably for high-rise building, for the cleaning process is very difficult. So this is the concept of the concrete can clean by itself. Although in terms of the cost, probably it's still a bit higher, but the technology is there. They use titanium dioxide on the surface of the concrete. Okay, so that's why whatever the water or the dust, whatever it is, so it can just one water that can being flushed through. Water quality concrete. Okay, the last one is on nano material in concrete. So nowadays we try to use smaller size of material. Become nano material. But nano material is very fine. Very dangerous. So we need to be proper protection when we want to use a nano material. However, the use of nano material improve the quality of the concrete, the properties of the concrete related to strength, related to durability, improve. So this is the things that nowadays researchers try to look into, improving the quality, improving the properties of the concrete. Okay, all right. So some of the applications: self-cleaning, self-healing, ultra high performance. So the use of nanomaterials in concrete. Okay, all right. So I think nearly 1 hour. So which means that whatever it is, the sharing, however, how you get the knowledge is not the focus, but the most important thing is knowledge is very important. Knowledge is power. Okay, through the knowledge, then we can invent something new. Yeah. All right. So this is my memory in India lah when I go to KPR. Is it Gokul?
Yes, sir. Yes, sir.
Yeah. Okay. Yeah. All right. So
okay, sir.
I no. Sometimes I show this to the student.
Okay.
If let's say before we start all this eating, and then the flag is up, isn't it?
Yes, sir. Yes,
when
sir.
finished, like this.
Okay.
So this one I don't remember the name, but it's very nice.
Okay. Madhav sir, please enable the chat box and mic for participants, sir.
Sure, sir. Sure.
Sure. So that's the participants. If you want anything to discuss, they will have interaction with you, sir. We are enabling them. Okay.
Yeah,
so participant, now so the session is open to you. If you want to discuss anything, you can discuss with sir.
Okay. All right. So thank you very much.
Okay. So thank you, sir. Thank you for nice, valuable session, sir.
Okay. Welcome.
So you written the Mick and Andri also.
I try to search it before.
I think you were keeping food also for Indian food. I think. Dosa.
Okay. All right. So thank you very much.
Take care, sir. Take care of your health also, sir.
In participant, the feedback link has been posted in the chat box. You can have access on that. For participants, the feedback link has been posted in the chat box. You can have access on that.
Stop presenting,
Yeah, you can stop presenting, sir. Yeah.
Stop presenting,
Yes, sir. If you want anything to discuss, you can discuss with the expert.
This chat box is one. This is the one. So anybody want to say something or share something?
Good evening, sir.
Yes.
Sir, I'm audible.
Who's talking?
So this is Rajesh from GMR Engineering College, assistant professor.
Okay, all right, yeah, okay.
Sir, I just gone through the presentation is very good, and it has really told all about your achievements and your findings in the research areas of concrete technology. I'm really impressed with your work, sir. Yeah, I have a doubt regarding the alkali activated concrete. Can I ask you, sir?
Geopolymer, is it okay?
Yes, sir. Can I proceed with my question, sir?
Yeah, sure.
Yes, sir. Thank you, sir. In order to make alkali activated concrete a permeable one, so can we have EM technology into that? Have you worked in that area, sir?
Oh, okay. On like a geopolymer concrete, alkali activated concrete, isn't it?
Yes, sir.
Okay, so I'm not focusing on that area, because that area also being researched nowadays, isn't it? It is good for the repair. It is good for get the early strength. But for structural application, it's still I think far away. Okay. So in order to improve the quality, because when we talk about alkali activated or geopolymer concrete, so we use sodium hydroxide. We have 10 molar sodium silicate and so on, isn't it?
Yes, sir.
So these things we need to consider, because nowadays we talk about the sustainability, because we talk about a green concept.
Yes, sir.
But if let's say we use so much chemical, it's very dangerous.
Yes, sir.
So these are the things. It is good, because this is we call as technology. Technology is being used to solve whatever the problem that we have.
Okay, sir.
Yeah. My
Thank
focus is not on the geopolymer or alkali activated. So my focus in terms of we can consider as a basic concrete. But if let's say we don't understand the basic concrete, and then we just go for the higher end of the concrete, then there will be a gap. There will be a problem.
Yes, sir. Yes, sir.
So
You
once
are
we
right, sir.
understand the fundamental, then we can proceed further.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Okay, thank you. Thank you. Anybody else want to share anything?
The group I have posted, sir.
Yeah. Who's talking?
Yeah, I think, sir, it's clear, sir. Thank you very much. I think participants, they are not having query. Thank you very much for your valuable session, sir. So
Okay.
thank you for bearing your valuable time for us.
Mm-hmm.
So we will be in touch with you, sir. The same thing, if any future, just we need your expertise and
Okay.
concrete, sir.
Sure, no problem. Sure. Knowledge to me is for everybody. Whatever the knowledge that we have, we need to share with everybody.
Okay.
Okay. All right. So thank
Okay.
you very much for for inviting me, and then please take care, everybody.
Thank you, sir. Thank you.
Sir.
Okay.
Thank you, and wish you the
All
same,
right.
sir.
So thank you. Thank you very
Okay.
much.
Participants, the feedback link has been shared in a WhatsApp group. It will be enabled till 6:20 p.m. Just 15 minutes time is there, and just you can give your feedback in that. So after this 6:20, we will be disabled that we cannot able to receive the response. So it has been posted in WhatsApp group also, sir. Participants, you can just look into that.
Okay. Okay. All right. Okay. Thank you.
Thank you, sir. Thank you very much, sir.
Okay. Thank you very much. So I can leave now, yeah?
You can leave, sir. Thank you, sir.
Okay, all right. Thank you. Okay, take care, everybody.
Thank you, sir.
Thank you, sir.
Wish you the same.
Okay, all right.